Now, just like when we added linear expressions, I did start by using models to subtract linear expressions. And you can see these examples here. I don't want to spend a lot of time with the models just because I know that that's not something I'm going to ask you to do on a quiz or a test. And it gets to be pretty challenging with example 3 when we're subtracting and taking things away. So for example, I have negative 3x minus 2, which is negative 3x plus negative 2, minus 5x plus 3. So I represented the negative 3x plus negative 2. And remember the negatives, we use those shaded long skinny rectangles or squares right here. But if I have to take away 5x, the problem with that is I don't have 5 positive x's to take away. So you notice that I have to add 5 positive x's and 5 negative x's, so I'm not changing the problem itself. Cross off my 5 positive x's, which results in 1, 2, 3, 4, 5, 6, 7, 8 negative x's. So it's kind of weird the way you have to add something to take it away. So I don't want to spend a lot of time on that. I do that also with the 0 pairs here. But if you're really interested in seeing how this could potentially work visually, take a look at this because it's an interesting thing where you add 0 pairs into your algebraic expressions or your linear expressions here so that you can take things away. But I don't want to spend time with that because I know that, again, it's probably not the most important thing for you to see, given that you're not going to be asked to do that on a quiz or a test. But it is a very interesting problem that we have. So here's the deal. The one thing I really want to focus on with these guided notes is the rules for subtracting linear expressions because it's harder than adding linear expressions. So I'm going to highlight this box here where it tells us the basic rules that we need to follow as we go to, and I'd highlight that the whole way over, but that's my box there, and I don't want to stop the video at all, so the entire box should be highlighted. But our steps for subtracting linear expressions are going to be as follows. Recognize this as something as one big add the opposite. So just like when we changed subtracting problems like negative 5 minus 12 into negative 5, negative 5 plus negative 12, we're doing a similar thing here with linear expressions. The very first thing I always do, though, is I add the opposite inside the parentheses first, just to make sure everything's addition and I don't miss any negative signs. And again, just like when we talked about simplifying expressions before, this is a really, 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 really important thing to do. So add the opposite inside the parentheses first. And then we do our massive add the opposite. We change our subtraction that's between the linear expressions to addition, kind of like we did here. And then I change all of the terms in the second expression, or the one that follows subtraction, to their opposites. So in this case, it's not just a single number, it's going to be an entire linear expression that we change to its opposite. And then it becomes one big addition problem, so you add the linear expressions just like we did before. Now, I will point out that I combine steps 2 and 3 together. I definitely do not combine 1 and 2 together, or 1, 2, and 3, but I do combine 2 and 3 together. So I change the subtraction to addition and each term in the second set of parentheses to its opposite in the same step, and I would encourage you to do that as well. All right, let's get right into our examples. So number 1, and there's some typed up for you as well. Feel free to look through those, but I think we can spend our time more efficiently looking through the examples that we need to do together. So number 1, 6x plus 8 minus 5x plus 12, subtracting those two linear expressions. Step 1 is to add the opposite inside the parentheses first. Well, I don't have any subtraction there, so I'm good with step 1. Check that off. Step 2 is going to be to change your subtraction sign between the parentheses to addition. And I'm going to do step 3 at the same time, which is to change each term in the second set of parentheses to its opposite. So positive 5x became negative 5x, and positive 12 became negative 12. So I added the opposite of everything in that second set of parentheses. It's like distributing the subtraction sign to both of those. Now, put your like terms side by side. That will be your 6x and your negative 5x, and then your two constants, 8 and negative 12. Let's combine those. 6x plus negative 5x is 1x. 8 plus negative 12 is negative 4. So I wrote this solution in 3 different ways. All are acceptable. 1x plus negative 4, x plus negative 4, x minus 4. I should have also included 1x minus 4 could also work as well. So any of those would be sufficient or correct. All right, number 2. Here we do need to do step 1. Add the opposite inside the parentheses. Negative 6x plus 11 stays the same, but negative x minus 9 is going to be rewritten as negative 1x plus negative 9. I do like to put that coefficient in there. Now, steps 2 and 3. Change subtraction to addition, and each term in the second set of parentheses to its opposite. Negative 1x becomes positive 1x. Negative 9 becomes positive 9. Now, let's put our like terms side by side. That'll be negative 6x plus 1x plus 11 plus 9. All right, combine those. What do we get? If you were thinking negative 5x plus 20, you've got it. All right, number 3. Feel free also to pause the video at any point and maybe try some of these on your own. I would wait for a few examples, though, until you feel a little bit more comfortable with this. Number 3, add the opposite inside the parentheses first. So negative 8a minus 4 becomes negative 8a plus negative 4. Now, steps 2 and 3, subtraction to addition, and each term in the second set of parentheses becomes its opposite. Negative 5a to positive 5a, and positive 13 to negative 13. Put those like terms side by side. Negative 8a plus 5a plus negative 4 plus negative 13. Let's combine them. Negative 8a plus 5a is negative 3a. Negative 4 plus negative 13 is negative 17. So my final solution is negative 3a minus 17, or negative 3a plus negative 17. All right, moving right along. Number 4, start off by adding the opposite inside that second set of parentheses. I also put a coefficient of 1 in front of both of the h's. So h minus 5 became 1h plus negative 5. Now, steps 2 and 3, subtraction to addition, and distribute that subtraction to that second set of parentheses. So 1h becomes negative 1h. Negative 5 becomes positive 5. Put those like terms side by side. We've got 1h plus negative 1h plus 5 plus 5. The h's cancel out. Do not write 1h because 1 plus negative 1 is 0h, which is gone. But we do need to do 5 plus 5 to get 10. All right, you didn't think you could get away with these problems without seeing some fractions and decimals. Let's see those. In number 5, add the opposite in that second set of parentheses to become negative 2/3 x plus negative 8. I forgot to change my parentheses to the big parentheses. No big deal. All right, steps 2 and 3. Subtraction to addition. Our negative 2/3 x is going to become positive 2/3 x. Let's get right here. And then our negative 8 is going to become positive 8 once we distribute that subtraction. All right, put your like terms side by side. We've got half x plus 2/3 x plus 3 plus 8. Final solution, if you're having trouble plugging anything into your calculator, please see me. I can help you with that. We should get 1 1/6 x plus 11 or 7/6 x plus 11. It looks a little cleaner to write it as an improper fraction, but both are correct. We are going to skip questions 11 and 12. You will not have problems like it on your test, but I do want to focus on the other questions. So during our live session, we would have talked about numbers 1 through 5. So I want to begin with question number 6 in lesson 5.7 guided notes. And again, you want to have these guided notes out in front of you. You want to make sure that you're copying down in detail each of these examples along with the work that goes with them. So in question number 6, I have two linear expressions that I'm subtracting, 8.5x plus 3.1 and 2.8x minus 5.6. The first step that we want to do when we subtract linear expressions is add the opposite inside the parentheses. So you can see that I did that. I'm going to highlight this in blue for us. So the 2.8x minus 5.6 became 2.8x plus negative 5.6. The second and third steps we can do together, and that involves us changing the subtraction sign that's between the parentheses, between your linear expressions to addition, and changing each term in the second set of parentheses to its opposite. It's one big add the opposite. So positive 2.8x becomes negative 2.8x, negative 5.6 becomes positive 5.6. Next thing we'll do is put our like terms side by side, which we're going to get to the point where we can skip this step and just recognize I want to add 8.5x to the negative 2.8x and 3.1 to 5.6, but I did rewrite them side by side here for us. This is where you want to use your calculators, so you can't plug the x in and you don't need to plug the x in. You just need to do 8.5 plus negative 2.8 and then separately do 3.1 plus 5.6. You can, of course, calculate it by hand or do it mentally, but you do want to double check in your calculators just to make sure you don't make any mistakes. So 8.5 plus negative 2.8 gets us 5.7x plus, and then 3.1 plus 5.6 gets us 8.7. So that's our final solution. Remember our three key steps. The first step, add the opposite inside the parentheses first. The second and third steps you do together. Change the subtraction between the linear expressions to addition, and each term in the second set of parentheses to its. All right, let's take a look at numbers 7 and 8, which are also on this same topic. So question number 7, the first thing I'm going to do is add the opposite inside the parentheses for both linear expressions. So negative 2x minus 9 becomes negative 2x plus negative 9, and negative 4x minus 6 becomes negative 4x plus negative 6. The second and third steps, we're going to change subtraction to addition, and each term in the second set of parentheses to its opposite. So we know that our negative 4x becomes a positive 4x, negative 6 becomes positive 6. Now let's put our like terms side by side. That will be negative 2x and 4x, and our constants, which are negative 9 and 6. Negative 2 plus 4 gets us 2x. Negative 9 plus 6 gets us negative 3. I do want to mention that you might see your solution written like this as 2x minus 3. That's equivalent to 2x plus negative 3. It's just one we've added the opposite, the other we haven't. All right, final example, number 8 here. There is an additional practice sheet that if you have not already received, you will get, but you'll have an opportunity to complete some additional practice on this concept. It's also something we'll practice in class with some additional examples. You'll see also on the review worksheet to help get some practice with this as well. So number 8, find the difference means subtraction, x plus 6 and negative 3x minus 4. So when I wrote down the problem, I added the opposite. That way we don't have to do an extra step. So I have x plus 6 minus negative 3x plus negative 4. Now steps 2 and 3, change subtraction to addition. Negative 3x becomes positive 3x, negative 4 becomes 4. You notice I also wrote x as 1x here. Put your like terms side by side. That will be 1x and 3x, and then 6 and 4. 1x plus 3x is 4x, 6 plus 4 is 10. So my final solution is 4x plus 10. All right, numbers 9 and 10. If I remember correctly, there's a question like numbers 9 and 10 that are on your test. So let's slide this ahead, and then I'll go back to some independent practice that I want you to try before we finish up the video as well, just to practice with subtracting linear expressions. Again, whenever I give this practice to you within the video, please make sure you do it. This is something we would typically do in class, but since we're not in class 5 days a week currently, I really want to make sure you do this practice as well. But first, let's take a look at numbers 9 and 10. So number 9, read it with me as I read it aloud. The number of customers in a store on the first day is represented by 7x minus 5. The number of customers on the second day is represented by x plus 6. Write an expression to find how many more customers visited the store on the first day. Then evaluate the expression if x is equal to 80. So whenever we have an example where we're trying to figure out how much bigger something is than something else, or how many more customers visited the store, that means we're going to subtract. So I'm going to take the number of visitors in the store on the first day, 7x minus 5, which I wrote as 7x plus negative 5. And I'm going to subtract off the x plus 6, which I wrote as 1x plus 6. So step 1 is done as I write the problem. That saves me an additional step. Steps 2 and 3. Change subtraction to addition. Change each term in the second set of parentheses to its opposite. 1x becomes negative 1x. Positive 6 becomes negative 6. Now let's put our like terms side by side. 7x and negative 1x, negative 5 and negative 6. 7 plus negative 1 is 6. Negative 5 plus negative 6 is negative 11. So our simplified form for our linear expression when we subtract those is going to be 6x plus negative 11, which, by the way, we can also write as 6x minus 11. Now for the second part of this question, they're asking us to evaluate the expression if x is equal to 80. So what I can do here is take my expression and replace x with 80. So let me move this down. So we do 6 times 80 plus negative 11. 6 times 80 is 480. Add on the negative 11 or subtract 11 to get 469 customers. This means we had a difference of 469 customers from one day to the next. An optional thing that you have that you can do to check your solution is replace x with 80 in each of these expressions and then subtract those answers to see if you get 469. I did this on my own just to double check my solution, just to make sure we got 469, and we do. So it does give you an option for checking your solution. All right, let's take a look at number 10, which is very similar to this one. The expression 4.5x plus 3 represents the number of miles Julia rode her bike, and 2.5x minus 1.2 represents the number of miles that Angela rode her bike. Write an expression to find how many more miles Julia rode her bike in x hours. If they each rode for 3 hours, how many more miles did Julia ride? So again, when we're looking at a situation where we want to figure out how many more miles or how much more of something than someone else, we're going to subtract. So we're going to take that 4.5x plus 3, subtract off the 2.5x minus 1.2, which I wrote as 2.5x plus negative 1.2. Change subtraction to addition, and each term in the second set of parentheses to its opposite. So you can see that I wrote 2.5x and I changed it to negative 2.5x. Negative 1.2 became positive 1.2. Let's put our like terms side by side. That's our 4.5x and our negative 2.5x, and then our 3 and our 1.2. 4.5 plus negative 2.5 gets us 2x, and 3 plus 1.2 gets us 4.2. Now the second part of this, like our last one, although it's written a little differently, it says if they each rode for 3 hours, how many more miles did Julia ride? So basically you're going to replace x because it says that x represents the number of hours. You're going to replace x with 3 in this expression. So we're going to do 2 times 3 plus 4.2. 2 times 3 is 6, and 6 plus 4.2 is going to be a difference of 10.2 miles. Again, like the last one, you could replace x in each of these linear expressions with 3, calculate the number of miles that each person rode, and then figure out the difference between them, and you will determine that that is 10.2 miles. All right, I want to give you a chance to do some independent practice before we see one more question from these guided notes, which is the multiple choice question number 13. Always important to practice those because I do sometimes find that students struggle more with multiple choice than with open-ended, especially since you don't get partial credit for those. So you really want to make sure that you're as accurate as possible with those multiple choice questions. Before we do that though, there's 2 questions here that I want you to try. Go ahead and pause the video, jot these down someplace where you have some space, perhaps above numbers 1 through 3, and then we'll take a look at these in just a few moments. All right, so hopefully you've tried these 2 questions. Let's begin with number 1. I'm going to go ahead and slide all of this out of the way. Final solution should be negative 10x plus negative 2 or negative 10x minus 2. So negative 7x plus 2 stays the same. Subtraction becomes addition, as you see right here. And then positive 3x becomes negative 3x. Positive 4 becomes negative 4. Put your like terms side by side, negative 7x and negative 3x to get negative 10x. 2 and negative 4 to get negative 2. So final solution, negative 10x plus negative 2. In question number 2, though, I do need to add the opposite before I begin. The solution for this one will be 10x plus 1. So 8x minus 4 becomes 8x plus negative 4. Negative 2x minus 5 we can rewrite as negative 2x plus negative 5. Then, steps 2 and 3, change subtraction to addition. Negative 2x becomes positive 2x. Negative 5 becomes positive 5. Now add 8x and 2x together to get 10x. Negative 4 and 5 together to get 1. So final solution, 10x plus 1. All right, I want to finish up this video by taking a look at the multiple choice question number 13. Again, I'm skipping numbers 11 and 12. That's not going to hurt you in any sort of way, but I definitely want to take a look at number 13. Whoops, I didn't realize that I still had this solution up here. Let's walk through this. Let me at least delete this other stuff and we'll walk through it together. My apologies on that. So taking a look at number 13, it says, which simplified expression represents E minus F? So as I'm looking through this, I know I'm going to take negative 7x plus 8 minus the 3x minus 12. I did add the opposite as I typed up, but I wrote down 3x minus 12 is 3x plus negative 12. Now, steps 2 and 3, change subtraction to addition. Positive 3x becomes negative 3x, negative 12 becomes 12. Again, you've got to remember those key steps. First thing is add the opposite. Don't try to do that with the other steps. Then subtraction to addition between the linear expressions, and each term in the second or following set of parentheses will become its opposite. So let's add negative 7x and negative 3x together, 8 and 12. Negative 7x plus negative 3x is negative 10x, which means I can eliminate, and this is why you saw these lines here at the beginning, choice A and choice C, and actually choice D at this point, because again, none of them have your negative 10x. A has a positive 10, and the other two start with 4 or negative 4, I believe it is there. And then 8 plus 12 gets us 20, just to confirm that choice B is our solution, and it is. We need to be really careful here, because again, the answer choices that I selected that are wrong are common mistakes that students make, where they forget to change the numbers following subtraction to their opposite. So they end up with negative 4x instead of negative 10x. Or where students maybe only change one number to its negative, or they don't add the opposite, so then they end up getting the second number, the constant, incorrect. So it's really important for us to take a close look at these expressions and make sure we solve it first before just trying to pick the correct solution. Remember that multiple choice questions, because you don't get partial credit, I think are even more important than those open-ended questions. So you really want to take your time with those. All right, we will get a chance to take a look at some more subtracting linear expressions together in class. So be ready for us to see that, because it's going to show up on your test, which is coming up very soon. Thanks for listening.